Okay, in this lecture video, we're going to talk about significant figures, what they are, and how many do you have when you write a number down, and a little bit about why it's important. So let's take the odds of winning the California State Lotto. It's 1 out of 76 million. So if I wanted to write that, I might write it like this: 1 out of 76 million. Or I could write that as 1 out of 7.6 times 10 to the 7th. That's the same thing. So if I were to do that math, I would get a number on my calculator that looked something like this: 0.0000000131578, and it would just keep going. Okay, so something like 1.31578, just put dot 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 because there's more numbers I could write down, times 10 to the minus 8th. That's an 8. So you get lots of digits out of your calculator, and the question is, how many do you write down? Sometimes it feels convenient to just round off to a whole number. Sometimes you feel better when you just copy down every single number you can. But really, we want to be as precise as we can. We want other scientists to know how confident we are in the measurement that we've written down. And we really don't know that what all of these numbers are. We can't be that precise. We only know in the beginning that it was 1 out of 76 million. So we need to express an uncertainty or an error in our measurement. And that's what significant figures allow us to do. It allows us to communicate with other scientists just by the way we write our numbers down, where our uncertainty or our error is in our measurement. So when we write a number down then, the error measurement, the way we communicate it is it's always in the last digit that we write down, at least specifically the last significant digit. So not all digits are significant when we record a measurement. Some of them are just placeholders because without them we couldn't write the number down. So the last digit is where the uncertainty lies. So let's take an example here. So in this example, let's say I have this long rectangle and I have a ruler with centimeters on it, and I want to measure this this bar. So when I look at it, I see that the measurement or the length of the rectangle is definitely 15 centimeters. And when I look really closely, I can say 15.2, so 15 and 2/10. And then you take a second and go ahead and write down what you think the next digit would be. It's somewhere, I would say, between the second and third little teeny line. So I'm not sure what you wrote down, but I'm going to write down 4. So to me, this bar looks like it's about 15.24 centimeters long. You might have written something else down. So what that's telling us is that this last digit here, in the hundredths place, that was our estimated digit. So that tells us where our uncertainty is. Sometimes we might express the level of the uncertainty. So you might write instead that you think the bar is 15.24 plus or minus 0.05 centimeters. That gives an even better idea of what your uncertainty might be. But right now, we're just going to focus on making sure that we always write down when we make a measurement, the last digit is our estimation, which is where our uncertainty is. And that's how we're going to be able to communicate to other scientists what our error is.